Right, in worksheet 12, we're going to be going over the sum, difference, double, and half angle formulas. In this video, we'll just be covering sum and difference, which are all of the formulas laid out here at the top of the screen, and going over how to use those. So in problem 1, for us to find the exact value of each, and I've started to show some of the work. So we're going to try to get the exact value of the cosine of pi over 12. Which isn't exactly one of the angles we know on the unit circle, but it is pretty close. So what I can do is rewrite pi over 12 as the difference between, this is 4 pi over 12 and 3 pi over 12. All right, so splitting that up, 4 minus 3 would be 1, giving us pi over 12. And both 4 pi over 12 and 3 pi over 12 simplify to something we know on the unit circle, that being pi over 3 and pi over 4. So now that I can rewrite the cosine of pi over 12 as the cosine of pi over 3 minus the cosine of pi over 4, I'll then use the cosine difference formula, highlighted here, to separate that expression out. So this should be the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. And then I can go to the unit circle to get each of those values. Cosine of pi over 3 would be 1/2. Cosine of pi over 4 is root 2 over 2. Plus the sine of pi over 3 is root 3 over 2. And the sine of pi over 4 is root 2 over 2. Putting all of that together gives us the square root of 2 plus the square root of 6 divided by 4. So in the next part of the problem, we'll look to do the same thing. Taking the sine of 17 pi over 12 means I first want to rewrite 17 pi over 12 as the sum or difference of two other angles that simplify. There are lots of different combinations that we could use here. I just need two numbers that add to get to 17 or subtract to get to 17, each of which has a common factor with 12. Oftentimes the easiest way to do this is to choose one of your angles to be 3 pi over 12, so I want something to be a multiple of 3, and have the other angle come out to be an even number, which we know will reduce with 12. So in this case, 14. So 3 plus 14 is 17. So I can say that this is equal to the sine of the sum of those two angles. Let's actually simplify these before we get into it. 3 pi over 12 comes out to pi over 4, while 14 pi over 12 reduces to 7 pi over 6. So the sine of 17 pi over 12, the same as the sine of pi over 4 plus 7 pi over 6. Now this is a sine sum formula, since I have the sum of two angles on the inside of a sine function. So I'll use the highlighted equation at the top. So this should be the sine of pi over 4 times the cosine of 7 pi over 6 plus the sine of 7 pi over 6 times the cosine of pi over 4. Then I can go to the unit circle to get each of those values. So it'll be root 2 over 2 times root 3 over 2. Plus sine of 7 pi over 6 is negative 1/2. And the cosine of pi over 4 is also root 2 over 2. Giving us negative root 6 minus root 2 all over 4. Right, then we're going to look at the tangent of 11 pi over 12. So I want to get two numbers that add up to 11, again, each of which shares a common factor with 12. So I'll look at 3 pi over 12, and it leaves 8 pi over 12. Simplifying each of those, I get pi over 4 plus 2 pi over 3. So I'm looking to get the tangent of pi over 4 plus 2 pi over 3. So since I have the tangent of two angles being added together, I want to use the tangent sum formula, again highlighted here at the top. So this will be the tangent of pi over 4 plus the tangent of 2 pi over 3 divided by 1 minus the tangent of pi over 4 times the tangent of 2 pi over 3. Plugging all of that in, tangent of pi over 4 is 1. Tangent of 2 pi over 3 is negative square root 3. Divide that by 1 minus, that'll be 1 times negative pi over 3. So 1 minus a negative, root 3. I think I misspoke a moment ago. Tangent of 2 pi over 3 is, again, negative square root 3. All right, in problem 2, we're going to look to use these formulas in the reverse direction. So this time, condensing a sum or difference formula backwards so that we can get a simpler solution. Hopefully that's something that's on the unit circle. So in this first part, I have cosine plus sine times sine. So highlighting each of those pieces, I know I'm looking to add two sides, and I have cosine times cosine plus sine times sine. Meaning that this must be the cosine difference formula. So this should be the cosine of 19 pi over 12 minus pi over 12. Since this particular formula fits the cosine model, the cosine difference model. So we can take the difference between those angles, makes this the cosine of 18 pi over 12, which is the cosine of 3 pi over 2 after we simplify. And the cosine of 3 pi over 2 is 0. We'll look to do the same thing with the next part down. This time we have sine times cosine plus sine times cosine. Or again, we're adding in the middle. But this time, instead of both cosines on the left and both sine factors on the right, I have a mix. I have a sine times cosine plus a sine times cosine. When the factors are the same, when I have both cosines together and both sines together, I know that's going to come out to a cosine formula. If they're mixed, I know it'll come out to a sine formula. So sine times cosine plus sine times cosine must be this formula here at the top. So I'm looking for the sine summation formula, which means that this expression should be equal to the sine of 19 pi over 12 plus pi over 12, which simplifies to the sine of 20 pi over 12, or the sine of 5 pi over 3, if I divide 4 into both 20 and 12. And the sine of 5 pi over 3 is negative root 3 over 2. Right. Problem 3. Now we're going to start mixing in some unit circle angles along with some reference angles. But we can still use the same formulas to solve these out. Keep in mind that anytime we take an inverse trig function, our solution always comes out to be an angle. So the cosine inverse of negative 99 over 101 is just some angle, which I'm going to call V. And I'll label over here in red. So that means that if I take the sine of the 3 pi over 4 plus cosine inverse of negative 99 over 101, I can just use the sine summation formula. It says this should come out to the sine of 3 pi over 4 times the cosine of V, so we'll just call that angle V, plus the sine of V times the cosine of 3 pi over 4. So we'll just need to finish solving that reference triangle. And if we do, we'll set up our Pythagorean theorem over here. 99 squared plus y squared is 101 squared. We'll end up getting that y is equal to 20. So since this was the cosine inverse of a negative number, I put my reference triangle in the second quadrant. And in that second quadrant, the opposite side, which is the y side, is positive. So the final step is to plug everything in. The sine of the 3 pi over 4 is negative root 2 over 2. Nope, that's in the second quadrant. So it's positive root 2 over 2. And the cosine of V is negative 99 over 101. Plus the sine of V we know is 20 over 101. And the cosine of V, or the cosine of 3 pi over 4, this time is negative root 2 over 2, since we are in that second quadrant. Okay. On to our next one. We have the tangent of the sine inverse of negative root 7 over 4 minus pi over 6. So again, we'll keep in mind that when we take the inverse trig, or the inverse sine of a number, our solution is an angle, which I'll label U, and then we'll create a reference triangle for U. It's the sine inverse of a negative number, so I'm putting this reference angle in the fourth quadrant, and we'll need to do some work to get that missing side. As it turns out, it's going to be 3. Since we'll have x squared plus root 7 squared is 4 squared. So it'll be 16 minus 7, which is 9. x is equal to 3. So, using one of our tangent formulas, this ought to be the tangent of u minus the tangent of pi over 6 divided by 1 plus tangent u times the tangent of pi over 6. Plugging things in, grabbing the tangent of u, which should be opposite over adjacent. This is negative root 7 over 3 minus the tangent of pi over 6, which is root 3 over 3. All of that divided by 1 plus tangent u, is root 7 over 3 times tangent of pi over 6, which is root 3 over 3. Right, and then the last part, this time we have two different inverse trig functions, which I'll relabel u and v to go with reference angles u and v. U would be in the first quadrant because root 11 over 6 is positive, and v is going to be in the fourth quadrant because negative 4 over 3 is, well, negative. And I'll get the missing sides, which from the Pythagorean theorem both end up being 5. So we have the cosine sum formula, which will be cosine times cosine u cosine v minus sine u sine v. So cosine u cosine v minus sine u sine v. Which will be one product minus another product. So from the u angle, which is in blue, I first want the cosine of u in slot number 1, and the cosine of that should be 5 over 6. And the sine of u goes in that third slot, right here. So right here, and our sine is root 11 over 6. Next, we'll go on to our angle v. First, we'll look at the cosine of v, which is the second slot. So right there, cosine of v is going to be 3 over 5. And then we'll get the sine of v, which goes into that fourth slot. That should be negative 4 over 5. Right, and then in problem 4, we have some given information. First, some information about u, which I'm highlighting in blue, and then some information about v, which I'm highlighting in red. So directly in the given information for u, we're told that that angle is between pi and 3 pi over 2, which is quadrant 3. And for that angle v, we're told that cosine is negative, and cosecant, or sine, is positive, which puts us in quadrant 2. So I've already put our reference angles in the appropriate quadrant. Now I just need to find the missing sides. So we'll go to the Pythagorean theorem once again. 21 squared plus y squared is equal to 29 squared, which means that y will be negative 20, since we're in the third quadrant. And same thing, but for angle V, make sure that's got a sharp edge to it. We want x squared plus 1 squared is equal to 7 squared, meaning that x squared is 48, 1 less than 49. So x is going to be plus or minus the square root of 48. And because we are in the second quadrant, we'll keep it negative. We'll choose the negative out of that plus or minus, I should say. And 48 is the same as 16 times 3. So all told, x is 4 square root 3, or rather negative 4 square root 3. And with all of that figured out, I have my 2 reference triangles, so I'm ready to start solving out each of the other problems. So I've already gone ahead and written out the appropriate equation, which you can always refer back to that list of equations when you're solving these problems. But each one of these are already written out for us. We just have to plug the right numbers into the right place. So we'll start with angle U, which is labeled in blue. First, sine U goes into the first slot, and the sine of U was negative 20 over 29. Next, cosine U goes into the fourth slot, at least the way that I have it written out. And the cosine of U is negative 20 over 29. For angle V, we'll put the cosine of V into the second slot, or that cosine of V should be negative 4 square root 3 over 7. And sine of V will go into that third slot. It is 1 over 7. Then if we wanted to simplify this, what does it come out to? This will end up being 80 square root of 3 minus 20. Should have been an 80 right there. Divided by 7 times 29, which is 203. All right. Let's do that same process, but for the cosine of U plus V. So starting with U, cosine U will go into that first slot. It was negative. Just realized there's an error in the previous problem. The cosine of U was actually negative 21 over 29, which means this simplified answer should have been 80 root 3 minus 21. Cool, so the cosine of U should be negative 21 over 29. And then we'll put Sine u into the third slot, it's negative 20 over 29. Go to angle V, cosine V into that second slot, so negative 4 root 3 over 7, and sine V into that fourth slot, which is 1 over 7. And this can simplify a bit. Looks like it's positive 84 square root of 3 minus a negative 20. All of that over 203. Okay, so for the tangent of u plus v, normally we would use one of the tangent sum and difference formulas, in this case, the tangent sum formula. However, since we've already calculated both the sine of u plus v and the cosine of u plus v, it might make more sense this time to just say the tangent of u plus v is sine over cosine, since I've already done the legwork to get each of those values. So I'm only doing it this way because I've already done the work to get each of those pieces. If I hadn't already done this work, it would probably be easier to just use a tangent sum formula, but here we are. So this is our top answer, 80 root 3 minus 21, all of that over 203, divided by our second answer, 84 root 3 plus 20, all of that over 203. And those two denominators reduce with one another, meaning our answer is just 80 root 3 minus 21 divided by 84 root 3 plus 20. All right, on to the next problem. The sine of u minus the cosine inverse of 5 over 13. So we've got another angle that we'll need a reference triangle for. Do this one out in purple, and I'll call it W, since we've already got U and V. Might as well just keep it, right there in the alphabet. So I'll label that angle W, and it's the cosine of 5 over 13. So I have an adjacent side of 5 with a hypotenuse of 13. And that means I should have an opposite side of 12, which I could get from the Pythagorean theorem. So I'll plug all that stuff in. The sine of u, which means we could go back up to the triangle above. The sine of u is negative 20 over 29, while the cosine of u is negative 21 over 29. So I'll fill in those two pieces. Negative 20 over 29 for sine, and negative 21 over 29 for cosine. And then I'll do the same thing for w. Cosine of w is 5 over 13, while the sine of w is 12 over 13. All right. Then, next part down, cosine of u minus 5 pi over 6. So again, I'll fill in those values from u. Cosine of u was negative 21 over 29, while the sine of u is negative 20 over 29. And then I can go to the unit circle for the other two values. Cosine of 5 pi over 6 is negative root 3 over 2, while the sine of 5 pi over 6 is 1/2. Right. And finally, the tangent of 4 pi over 3 minus v, which means we'll need to get the tangent values for v. Scroll back up to that reference triangle. And the tangent of v, which should be opposite over adjacent, looks like it comes out to 1 over 4 square root 3. So we'll fill that in for tangent v, negative 1 over 4 root 3, negative 1 over 4 root 3. And then we'll get the missing tangent 4 pi over 3, which is a value we know off of the unit circle. That's in the third quadrant, so both of these should come out to positive square root 3.